Okay, so getting ready for this second test here, I want to really tell you what's on the test without telling you what's on the test. So I want to go through this and kind of talk to you a little bit about what to expect. Now, first thing, it's Math 213, Math 212, same thing. Okay, so 2.6. What were the big ideas out of there? Well, we were talking about mins and maxes. We were talking about finding, you know, optimal, you know, profits and costs and all those kinds of things. And those really came into the word problems, but it was that idea. So what do you expect? Well, I'm going to tell you right now. We always give you how do you tell if this is a min or a max given information? So, given information about the first and second derivative, what can you conclude? Meaning, you're not going to actually find the derivative. I'm just going to tell it to you. I'm going to say, here it is. Or, I'm going to give you a number line and ask you to read it. Or I'm going to give you points and values, like something like this: f of 2, f prime of 2, f of 2 equals 4, f prime of 2 equals 0, f double prime of 2 equals 3. What does that mean? Is there a min or a max? That kind of thing. How do you answer those questions? So think about that one. How would you answer that? Well, if you really understand what was going on, you don't need to do all that other work that we were doing in the chapter. You'd say, look, derivatives equal to 0, which means it's a min or a max. So now how do I tell? Well, I don't have enough information to be able to draw a number line, but I do know my second derivative. My second derivative is a positive number, which means we are concave up. So if we're concave up, then what does that mean? We are looking at a minimum. So it's those kinds of questions. What do you need to know for an inflection point? What is a second derivative value, information? So you're going to see some new looks, but it's the same old, same old, same old. So if you really understand how do you read a first derivative, how do you read a second derivative, how do you make the number line, you'll be fine. There's nothing magical there. And all you're going to tell me is a min, it's a max, whatever. Okay, so then we also will give you some problems where we're just going to straight ask you, find the min, find the max. Here is a function, right? So we'll give you something like this: given a function, determine where it's min or max, using first derivative number line, second derivative number line, that kind of thing. And then also, this one doesn't have bounds. What if it did? Oh, here we go. So like we see that in 2.7. Here's your optimization, right? So find the min or max, and then find the min or max given endpoints. So remember to check those endpoints to see if they are actually the absolute mins and maxes. So those are there. That's the 2.7. So and then what I'm trying to think of what else out of 2.6 is really big, because 2.6 and 2.7 kind of bled into each other. Increasing, decreasing, using that first derivative number line to talk about, just made those up, right? The intervals of increasing because it's positive, intervals of decreasing because it's negative. Really go back, make sure you really remember all of that, because there will be questions on that. And then just derivatives. Right? This is a cumulative test. So there could be stuff previously from previous sections. And so I'm telling you right now, I'm looking at problem number 2 on your test. Well, it could be problem number 2. I change things around every once in a while, but this is problem number 2 on last semester's test. It was just find the derivative. And no, these are not just going to be power rules. These are going to have quotient rules, logs, exponentials, chain rules. It's the whole gambit. So you got to be ready. And no, we're not going to ask you for just first derivatives. We're going to ask you to find the second derivative. Be prepared. Just with your derivative rules, make sure you've refreshed them. Okay. Then getting to 2.7, we've already kind of talked about that. So that's the mins and maxes. Then 2.9. What was 2.9? Well, that was 2.7 with words. So here's going to be my big tip to you. Okay. Break it down into types of word problems. All right, and I'm going to help you out here. We had geometry, right? Geometry word problems. That's like what you're seeing down here. Find you're building a garden and you have this much feet of fencing. Like those kinds of problems. Or you're building a box, or something. But we always ask you, geometry is going to be rectangles or triangles. So you need to know your area, which is base times height, or your perimeter, which is um, you know, uh, 2 bases and 2 heights, so 2b plus 2h, and just be ready, because maybe you're building a fence against the side of a building, right? So this is your house, so therefore the perimeter wouldn't be 2 b's and an h anymore. Now it would just be 1 b and 2 h's. So just you have to be ready to go and think and demonstrate you understand. There's not going to be any Peter repeat. There's not going to be any memorization of problems, but you should definitely recognize the style and know what avenue go down. So if it's saying maximize area, you're like, okay, boom, rectangle, let's go. Then we are going to have just profit, revenue, all those things. So profit equals revenue minus cost. So you're going to want that one, and you're also going to want to make sure you have revenue equals the price per item times the number of items, right? So we like to give you something that's dealing with those, and we might either ask you to maximize the profit, minimize the cost, something of that nature. But you'll need those relationships. So there's always one problem like that where we're just going to give you, something like a formula and say find the derivative, maximize the profit, or something. So just be ready with that, and be ready to, kind of think about if, in words, where's my profit, where's my cost, where's my revenue, how are they explaining it to me. Um, be ready for marginal profits. Okay, so number one was geometry. Number two is going to be your kind of your profit equals revenue minus cost type situation. These are just going to be like derivative equal to zero. Like we're going to basically give you the function. You just need to take the derivative of it. You maybe need to take pieces and set it up, but it's going to be the derivative equal to zero. Okay, number three is going to be marginals. Marginal cost, marginal profit, finding those, and making sure you can interpret the answer of that. So make sure you seek out marginals. And then four is those problems. I kind of see them as they're really based off of the revenue type equation, that kind of idea, but it was the problem like we did in the notes. I forget exactly which one we did in the notes. I think it was the rebates and the TVs where you're setting up the change. I'll just kind of reference it as a rebate type problem, that the rebate type, where you are looking at how things are changing. You have your starting amount. We're starting with a price of $150, and then we're minusing some amount with our rebates that are each $4 each, but then our quantity of TVs is 600 TVs, and that's going to go up 100 TVs maybe per rebate that we offer, $4 rebate we offer, or something. So it's kind of setting up those types of problems. So those are your four major word problems. I would expect one of each on the test. Okay. Then, so go back and find those problems, practice those problems. Make sure you're doing them out of the book, doing them out of more. Go to all the different places you can that you have problems, because they're going to be there. Then 2.11, we're going to have find the derivative of a function where it's not possible or easy to solve for y, aka implicit differentiation. There's going to be one of those. And then there will also be one of the related rates. Those should be, oh yeah, there it is, related rates. So that's, the related rates were where you had a function, maybe area equals pi r squared, where I'm going to do the derivative with respect to time. So it would be dA dt equals pi times 2r dr dt. And then you'd have to go through the word problem to find what values to sub in for r or dr dt or dA. So search those ones out, and that's your test. That's your whole test. So the thing is, I don't want you to undersell it, because this is actually one of the hardest tests in the whole class. So don't understudy this one. But I want you to be, and the thing that makes it hard is these four word problems. Is you have to understand the big concept and then be able to find the problem. Which one am I looking at? There's going to be one of each, and then for some reason derivatives. Don't forget to go study those. Don't forget to go study those exponentials, base not e, right? Base 4, base 2. Make sure you study your logs, the log derivatives. Okay, I hope this helps you feel more prepared for the test.